In today's You Ask, I Answer, Kevin asks, what's the difference between refined and unrefined data? This is in response to a discussion thread we were having with the PR student chat on Friday about the usefulness of data. One of the things I like to say is that data is the new oil, which is a great analogy. This is an expression I heard first in 2006. And when you think about it, it makes total sense because data by itself, like crude oil, not super useful, right? It's kind of messy, sticky, gunky. The crude oil doesn't burn very well. Unrefined, uncleaned data doesn't analyze very well. Certainly doesn't give you insights and things. So, what does it mean when we talk about refined versus unrefined data? Data has to go through a process, the same as crude oil, in terms of how we turn it into a usable product, and that's the data lifecycle. So let's go ahead and bring this up here. This is the data lifecycle. From red to green around the circle, all the different steps that you need to be able to take to process your data and turn it into something useful. So each step can take a tremendous amount of time depending on the size of the data, how clean it is, where you're getting it from, whether it has to be merged with any other forms of data. So all that stuff has to be taken into account as you start working with your data. So let's dig into this. What exactly is in the box, as it were, when we're talking about the data lifecycle? You first have to ingest your data, which means you take it in from whatever sources you have gotten your data from. That could be databases. It could be unstructured data like social media data or news articles. If we're talking about public relations, it could be machinery data or aircraft engine data, depending on what kind of data we're working with. We've got to ingest it, which means we've got to take it in and get it into some kind of format that we can then start to work on. The next thing you do is you do your analysis. You look at the data and see what condition is it in. This is the first step in what's typically called exploratory data analysis. And this is what data is missing, what data looks like there are anomalies, are there formatting problems, things like that. Once you've done your analysis, you repair it. How do you fix the data, make it compatible with the systems you're going to be working with? You fill in missing values if you need to through imputation, stuff like that. The next step is to clean the data, which is to remove incorrect data. Again, depending on what you're working with, this could be system anomalies, this could be interference. If you're working in public relations and you're trying to get an understanding of a media space, you have to, really for the last year or so, you've had to include filters for certain politicians by name because they seem to soak up and inject themselves into every single news story that has even things that have nothing to do with your client. So that's sort of this cleaning process. Once you've done the clean, you prepare the data for analysis. And that means typically restructuring it as needed, reformatting it. So for those who are database geeks, this is going from either normalization or denormalization, making data work with the software that you're going to be working with. The next step is augmentation, which is when you take data and you add additional data to it. This is especially important in machine learning, where you'll need to classify or quantify or provide other insights to your data. So that may mean, for example, turning qualitative variables into semi-quantitative by transforming it into dummy variables. You may need to add additional data from the outside or merge in additional data sets. Once you're ready to start processing the data, you begin by more exploration. What are the connections? What are the correlations? And what are the unusual things you can find in the data? You compare it, especially if you're doing machine learning, with other models. If you are doing validation, you'll have a training data set and a test data set, but you're going to compare your data to other known good data sets to make sure that you're getting valid conclusions or potential conclusions. And then you move on to really what's the predictive portion of the data, which is in a lot of ways like a hypothesis in the scientific method. I mean, it is a hypothesis from the scientific method. You predict what the data tells you, and then you prescribe or you come up with a solution for what to do based on that data. And depending on the model you're building, that may be something that a human does. You may hand off that. That may be a part of the process where you hand off some analysis to another part of the business. It may also be a machine that does the prescriptive work that says, okay, I'm going to take all new data and use it and match it up with the existing data. This is modeling. This is the modeling portion where you take all of those predictions and prescriptions and turn them into machine rules, ways that you can deploy your data in a scalable way. And then you validate the model, you test it, make sure that it works, as intended. And in many ways, you check to see, is your hypothesis correct or incorrect? Is it true or false? As with all things in the scientific method, a hypothesis is a true or false statement. So you want to make sure that your data gives you, your model gives you that answer. Once you've validated it, you move on to refining it. How can you tune it up and improve it without overfitting it to make it as accurate as possible, as refined as possible? And then you deploy your model across your business that can help all the business users with their data. And then you observe what happened when you rolled out this model. Did the end result that you were looking for get better, or did you create a result that you didn't have before? Now, that is a lot to cover in just about 5 minutes here of the data lifecycle. But all of these steps are connected. Some of them are automated, some of them are not. Some of them use human judgment, some of them use machine judgment. But all of these are parts of this data lifecycle that you need to go through in order to really get the most out of your data, to turn it into that refined product that that the business can use, that your users and your business stakeholders can make practical use of. When you think about measurement and analytics in whatever discipline you're in, from public relations to transoceanic shipping, the one thing that's missing from this is sort of the overall strategy. What's the goal of the data? And that happens outside of the life cycle. That happens before you even touch data. Is what's the goal, and then and how do you know you're going to get to the goal? What tactics, what choices will you make, and then how will you execute the data life cycle? So that's the one thing I would say that's not here, that it is presumed that you have done in advance before you start working with data. In order to make refined data can take a very long time to put together. Refined data can be very difficult, very expensive. Again, that's why data scientists are in such high demand right now. And so be prepared for that when you begin your data journey. Be prepared that it's going to take a while, and that the answers will not always be obvious, and that it will take a lot of effort to turn it into a truly usable product. But once you do, your business will scale faster than you can possibly imagine, because you've got the data and other people don't, or other people's data may not be as good if they haven't followed the process as well. And that's how you turn your data into a competitive advantage. You execute the data lifecycle better and faster than your competitors. That's why artificial intelligence and machine learning are so critical now to data, because the value of AI is acceleration and accuracy. Better data, faster data. So you go from data to insights to deployed strategies so much faster when you have AI on your side. So great question, Kevin. Great discussion about how we can be using data. And as you can see, no matter what profession you're in, this is going to have a major impact on every line of business. The faster you get to embrace machine learning and artificial intelligence, the faster you'll take advantage of the data you have and turn it into business impact. Thanks for the question. As always, please subscribe to the YouTube channel and the newsletter, and I'll talk to you soon. Take care. If you want help with your company's data and analytics, visit braintrustinsights.com today and let us know how we can help you.